Good morning viewers, myself Raja Soorya from the Computer Application Department, SFR College, Sivagasi. So in this video, we are going to see about linked list in data structure. So let's start the topic. So first of all, we'll see that what is linked list. So linked list, it is a linear collection of data elements. So these data elements are called nodes. Here the linear representation can be given by link, that is they have given the link from one node to another node. So unlike an array, we cannot access data by random access in this linked list. So in linked list we can access the data only by sequential manner. So next we will see the basic terminologies in linked list. So in this figure you can see that it is the basic representation of linked list. So we can see that in linked list which every node contains two parts. One is that data part and another one is the pointer to the next node. So the left part, that is the integer part in this figure, it contains data, either simple data type or array or structure. The right part of the node contains a pointer to the next node, that is the address of the node. So the last node will have no next node. So it will store a special value called null. A null pointer denotes the end of the list, and every linked list it contains a pointer variable start. So in this figure itself you can see that they have mentioned that start for the first element. So every linked list it contains a variable start, it stores the address of the first node in the list. We can traverse the entire list using start, and the next part of the first node it stores the address of its succeeding node. So if the start value equal to null, it means that the linked list is empty and it contains no nodes. So in C we can implement a linked list by using this struct code only. So this is the sample code for the implementation of linked list in C language. So next we will see that memory allocation of linked list. In order to form a linked list, we need a structure called node. It has two fields, data and next. So already we know that data it stores the information part and next it stores the address of the next node in the sequence. So in the figure the start value it mentioned it as 1. So the first data is stored at address 1. So in the figure you can see that in address 1 they have stored the first value h. The corresponding next stores the address of the next node, that is 4. So the next it traverses to the address 4 and it takes the value e. So likewise it repeats this procedure until it reaches the position where the next entry contains -1 or null, that is it represents the end of the list. So we can maintain two linked lists together in a computer memory. So here in this example it is mentioned as the 11th students, they can choose either biology or computer science. So we will maintain two linked lists for each subject, that is the first linked list it contains the roll number of the students who have chosen biology, and the second linked list it contains the roll number of the students who have chosen computer science. So in this example there is no ambiguity in traversing through the list because each list maintains a separate start pointer which gives the address of the first node of their respective linked list. So here in this picture you can see that for the students who have chosen biology, the start value it is pointed to number 1, that is address 1, and for the computer science the start value is address 2. So likewise when we take the biology students from this list, first we will see that SO1, and in SO1 the next address it is mentioned as 3. So we will traverse through address 3 and then we will take the SO3, and next for the SO3 the pointer address is given as 8 and next we will move to address 8. So likewise the rest of the nodes are reached by looking at the value stored in the next. Here I have given the output for this for the biology students and computer students. For biology 1, 3, 6, 8, 10, 11. For computer science 2, 4, 5, 7 and 9. So, the same way followed for both at computer science and biology students. So, next we will see the difference between linked list and array. Both linked list and arrays are a linear collection of data elements. But unlike an array, a linked list that does not store its nodes in a consecutive memory location. And another difference between an array and linked list is that linked list does not allow random access of data. Nodes in the linked list can be accessed only in a sequential manner. So, but like an array, insertion and deletion can be done at any point in the linked list in a constant time. So, based on the size, if we declare an array as, here I have given the example int marks of 20. So, in this array we can store a maximum of 20 data elements only, but there is no restriction in case of linked list. So, linked list provides an efficient way of storing related data and performing basic operations such as insertion, deletion and updation of information at the cost of extra space required for storing the address of next node. But in the array we cannot change the that is memory space. So, this is the major difference between linked list and array. Next we will see about memory allocation and deallocation for a linked list. If we want to add a node to an already existing linked list in the memory, we find the free space in the memory, then we use the free space to store the information. So, in this figure you can see that the grey shaded portion, it shows the free space. So, here we can find out that we have 4 memory locations available. So, we can use any one of them to store the data. When we delete a node from the linked list, a question arises, that is, who changes the status of the memory occupied by it from occupied to available? So, the simple answer for this question is the computer does this operation on its own without any intervention from the user. So, the computer, it maintains a list of all free memory cells. So, this list of available space is called free pool. So, every linked list, it has a pointer variable, already we know this. So, for the free pool also, it has a pointer variable avail which stores the address of the first free space. So, in this picture you can see that avail, it shows the first free space in the memory. So, for example, when a new student record has to be added, the memory address pointed by avail will be taken and used to store the information. So, if we want to add any new information for this, so we will store the information in address 4 only. After the insertion, the next available free space address will be stored in the avail. So, next available free space is number 6. So, if we store data in address 4, the avail pointer, it moves to address 6. So, likewise it just use the free space available in the memory. And last one is garbage collection. The operating system scans all the memory cells and mark those cells that are being used by some program. Then it collects all the cells which are not being used and add their address to the free pool. So, already we know that in the free pool it has only the free memory cells only. So, the OS itself, it stores the free space in the free pool. So, this is called garbage collection. We can use this free pool maybe for some other program. So, this is the main term in the linked list. So, in this video we saw about what is linked list and the basic terminologies we are using in the linked list and how we store the linked list in memory, the difference between arrays and linked list, and at last memory allocation and deallocation methods for the linked list. And we know that we can implement stacks and queues using linked list. This is a major application for the linked list. And it handles collisions in hash table also. We can represent graph using this linked list, and already we know that we can allocate and deallocate memory dynamically using this linked list. So thank you for watching